Hello. In this video, we're going to look at the process of data collection and how we design experiments for statistical studies. Most of it's going to be a lot of vocabulary, so just be aware. Beginning, the goal of every statistical study is to collect reliable, by reliable we mean unbiased, representative data, and use the data to make a decision. So when designing a statistical study, there's a variety of steps that we go through. The first thing is we identify the variable or variables of interest, the focus, and the population that we are wanting to study. Second step is develop a detailed plan for collecting data. If you use a sample, make sure the sample is representative of the population, and that's key. Then we collect the data. We describe the data using descriptive statistics and techniques. We make charts, we make tables, we look to see what patterns are there. We interpret the data and make decisions about the population, then using inferential statistics. What inferences can we make about the population as a whole? And then the last part is we identify any possible sources of error. There are two types of studies that you can conduct when you're developing your plan. There's what's known as an observational study. An observational study is when a researcher observes and measures characteristics of interest of part of a population. So they are not changing the population. They're just simply observing it in its quote-unquote natural habitat. Researchers observed and recorded the mouthing behavior on non-food objects of children up to 3 years old. So that's an example. Observational studies are used a lot with children because you just want to see how they're naturally behaving, or you give them like a puzzle and let them try to solve a puzzle or something maybe like that. So an experiment would be when you induce some treatments. So a treatment is applied to part of a population and responses are observed. So you're actually changing the natural setting and seeing how that affects the end results. So example would be diabetics took cinnamon extract daily while a control group took none. After 40 days, the diabetics who had the cinnamon reduced their risk of heart disease while the control group experienced no changes. After you have decided what type of study, you need to decide on the type of data collection. So a simulation is a type of data collection that uses a mathematical or physical model to reproduce the conditions of a situation or process. It often involves the use of computers. For example, automobile manufacturers use simulations with dummies to study the effects of crashes on humans. So simulation is when it would be unethical and in order to actually create a study that was done on actual people or animals or anything. So a survey is an investigation of one or more characteristics of a population. They are commonly done by interview, internet, phone, or mail. A survey is conducted so an example would be a survey is conducted on a sample of female physicians to determine whether the primary reason for their career choice is financial stability. So that's two types of data collection. In this example, the goal is to determine which type of study, observational, experiment, or method of data collection, simulation, or survey would be most appropriate for each situation. So example one, a study of the effects of changing flight patterns on the number of airplane accidents. So this first one would be a simulation. It's impractical to create the situation in real life. It's definitely unethical, so the solution would be this is going to be a simulation. Second one, a study of the effect of eating oatmeal on lowering blood pressure. Well, for this one, you can actually conduct an experiment. You'd measure the effect of the treatment on eating oatmeal and then see if it actually does lead to a situation where you have a lower blood pressure. Can I give you a chance to try? Your task is to determine which type of study, observational or experiment, or method of data collection, simulation, or survey would be most appropriate for each situation. So first one, a study of how fourth grade students solve a puzzle. Situation number two, a study of U.S. residents' approval rating of the U.S. president. So I'll give you a moment, pause the video, come back and see how you did. Okay, here you go. The very first one, and I referenced this earlier, this would be an observational study. You would simply observe and measure certain characteristics of part of the population, just the students. You give them a puzzle, let them try it, and you know what you see. The second situation would be a survey. Simply ask, do you approve of the way the president is handling his job? So there we go. You get an example of all the 4 different types. Next aspect we're going to look at are the key elements of experimental design. What makes the control? Why do we use randomization? What role does sample size play? And how important is replication? So very first part, control. Control, you would like to control for effects other than the one being measured. You use this in scientific studies all the time. So what you're trying to do is you're trying to avoid confounding variables. Confounding variables occur when an experimenter cannot tell the difference between the effects of different factors on a variable. A coffee shop owner remodels her shop at the same time a nearby mall has its grand opening. If business at the coffee shop increases, it can't be determined whether it is because of the remodeling or the new mall. So you would like to control for the effects other than really what you're after. In order to do this, sometimes a placebo will be used because of something known as the placebo effect. So a subject reacts favorably to a placebo when in fact he or she has been given no medical treatment at all. So in order to account for the placebo effect, there's something done called blinding. Blinding is a technique where the subject does not know whether he or she is receiving a treatment or a placebo. A double-blind experiment is a technique where neither the subject nor the experimenter knows if the subject is receiving a treatment or a placebo. So if this was some medical study, one person might be given a pill, one person might with the actual medicine, and one person might be given like a sugar pill. So blinding is when the person doesn't know whether they're receiving the actual medication or whether they're receiving a sugar pill in order to avoid the placebo effect where somebody is kind of psychosomatic in making themselves feel better because they think that they're receiving some type of medicine. So you want to control for that placebo effect by doing blinding or a double-blind experiment. The following are key elements of experimental design, the importance of randomization. So randomization is a process of randomly assigning subjects to different treatment groups. You will decide who's going to get the treatment, who is not, and you want to use randomization. So completely randomized design is when subjects are assigned to different treatment groups through random selection. We'll show you how to do this in a little bit. So a randomized block design is when you divide subjects with similar characteristics into blocks, and then within each block randomly assign subjects to treatment groups. So a completely randomized design would be when everyone is equally likely to receive some treatment, whereas in a randomized block design you might split people up first based on age or gender or another characteristic you want to kind of get equal representation for, and then within each of the groups you're going to randomly assign subjects to treatments. A randomized block design is what we were talking about just the last part. Just to give an example, I talked about you can do age. So here's an example. An experimenter testing the effects of a new weight loss drink may first divide the subject into age categories. So they divided them into those that are between 30 and 39, 40 and 49, and then over 50. Then within each of the age groups, they randomly assign subjects to either the treatment group or the control group. So the idea here is that you don't want to get a situation just through random assignment where you have a larger ratio of maybe the control group turns out to be mostly 50-year-olds. Well, that wouldn't be representative based on age because you want to control for age. So you split up based on age, and then within each of the groups you decide who's going to have the control and who's going to have the treatment. Key elements of experimental design. What role does sample size play? Well, sample size, obviously the number of subjects in a study, is going to be very important to the experimental design. The kind of rule of thumb is that a study usually requires at least 30 subjects in each group in order to begin to validate some results, and that'll be what we refer to later is that there's some replication aspect to it. So replication is the repetition of an experiment using a large group of subjects so that it's repeatable and you get similar results. Sampling techniques are all the variety of ways once you've decided how you're going to split up your groups, who's going to receive the treatment, who's not going to receive the treatment. These are how you decide how you're going to sample. So what you're trying to do is the number one item is you're trying to avoid bias. So bias is an error that results in misrepresentation of a population. It occurs when one conclusion is favored over another based on the actual sampling procedure. So to avoid bias, there are 5 ways to conduct a sample, and some avoid bias more than others, and it just depends on the context. So the first one we call a simple random sample. It's when each member of a population has an equal chance of being selected. So example would be a principal randomly selects 100 students from the school for something, and he or she does so using student ID numbers. Typically, simple random samples are the best way to avoid bias. You're just letting randomization play the role, and you wouldn't have any inherent bias in there. A systematic sample is when members are selected according to a specified interval from a random starting point. So for example, maybe students are sorted by their ID numbers, a random starting number is selected, and then every fifth student is asked to participate after that. So you assign, everyone has a student ID number. You randomly pick a number, maybe the number 120. And then what you do is you sample every fifth. So you will sample student with ID number 125 and 130 and 135 and all the way through until you have as many as you would like for your study. Sampling technique number 3 would be cluster sampling. Cluster sampling is when the population falls into naturally occurring subgroups. They each have similar characteristics. So all students with the last names that start with J, S, and M are selected for a study. A convenient sample is when members who are readily available or easy to reach are selected. So it might be the principal doesn't want to try to get all people to come to a room at lunch or something like that. It might just be hard to obtain. So what he or she does is they decide to stand outside where the buses drop students off as they come in to school, and they're going to ask students as they come off the bus. So as students who ride the bus exit, they are surveyed. So convenient samples, because it's convenient. Sampling procedure number 5 is called a stratified sample. It comes from strata, meaning groups. So the population is first divided into similar, non-overlapping. Non-overlapping meaning that there's nobody who is in more than one group. And then members are randomly selected within each of the groups. So using ID numbers, the principal randomly selects 50 from each grade level. So 50 freshmen, 50 sophomores, 50 juniors, and 50 seniors. Stratified sampling is used when you want equal representation from different groups. You don't want to just randomly oversample seniors or freshmen or something like that. That might lead to some inherent bias. The reason that we have all these procedures is because we want to avoid bias. And one of the ones that we talked about is maybe you want to randomly sample some people. And the reason that we are going to use computers is because it is difficult for humans to be random. And so if you are in class on this day, I do the following activity. I ask all students to imagine a perfectly weighted, random, and fair coin. And I want them to flip it in their head 30 times. If you want to, you can even pause the video right now and try it for yourself. On a piece of paper, imagine flipping a coin 30 times, and I want you to make a list of the results of those 30 flips for your perfectly weighted, random, and fair coin. So example, you might do heads, tails, tails, heads, whatever you think. So maybe write down the 30 results that you have in your head right now. You can pause the video, and I'll tell you why I have this activity in class. So pause the video now, otherwise a little spoiler alert. So next, what I show students is that it turns out people are terrible at being random. We are highly predictable creatures. So for example, in their list of 30, that is, for the 30 coin flips that I asked people to do in a class where I had done this in a prior year, it turns out that the longest streak of either heads or tails was at most 3 for 11 of my students. There were 6 students in the class who put a streak of, their longest streak was 4, and there were only 2 in the class who had a streak of 5 or more. So in percentages, that is 58% of the class only had a streak of 3. 32% only had a streak of 4, and only 10% had a streak of 5 or more. The reason this is interesting is because when you actually do this in real life, so I simulated this using a computer. I did 100 iterations of 30 coin flips. It turns out that 13% of the time, the longest streak was only 3. 26% of the time, there was only a streak of 4, but 61% of the time, in 30 coin flips, you're going to get a streak or 5 or more. Whereas if you look at what humans do, they only do it 10%. The problem is humans think that randomization means equal, that you need to have an equal amount of heads or tails, and it needs to alternate pretty frequently. Well, that's not what randomization means. Randomization means unpredictable. And when you have unpredictability, there are going to be natural patterns that actually just occur. You just don't know when they're going to occur. And one of those natural patterns is there are going to be repeatable occurrences of heads or tails. And it turns out, well, 61% of the time, in this case, you're going to have a streak of 5 or more, whereas humans think it's only going to be about 10% of the time. So if we are so bad at randomization, it's important that we use computers in order to be random and unpredictable to avoid bias. So here's a situation, and you'll need your calculator in order to do this. There are 731 students currently enrolled in math classes at our school. You wish to form a random sample of 8 of them, so you sort them alphabetically and assign each a number from 1 to 731. To select 8 random students, you can use the random integer generator on your calculator, since we are so terrible at being random. And so the directions are right here. So it's for TI-84, or it could be TI-83 would be fine too. So you're going to choose the probability menu, then you're going to hit 5 random integers. So with the calculator, you're going to hit math, and then work your way over to probability, and you'll see option 5 says random integer. With the TI-84, it will ask you, it'll prompt you for these things. For a TI-83, it will not. You'll have to know the very first thing you're entering is the lowest number, the second item you're going to enter is the highest number, and the last number is how many you would like to select. So in our case, the lowest number was a 1. The highest number was a 731, and we were selecting 8. And when I do so, and I hit enter one more time, it will tell me what those 8 numbers are. So, person 728, person 147, person 584, 696, on and on. You can scroll over. Those are the people that would be actually selected for the study, and that avoids any inherent bias that I might have in randomly picking 8 numbers, since we are not good at that. Last part is I'm going to give you a chance to identify the sampling technique and whether you believe that this is biased or unbiased for the situation. So first situation, in order to obtain the opinions of high school students, students in a biology class are selected and surveyed regarding their opinions on stem cell research. Last one is the CEO of a large company divides his employees by gender and then randomly selects 20 from each to participate in a survey. So pause the video now and come back and see how you did. Okay. So the first task was to identify the type of sampling that was being used. For the first one, it could be identified as either a cluster or a convenience sample. Cluster being that they all share the fact that they were in a biology class. Most people are probably going to call this a convenience sample, though. And there's a problem with convenience samples is they tend to be inherently biased. And the reason that this one is biased is because the population of interest was all high school students. But we only selected those that were in a biology course. And if we select those that are only in a biology course for a survey about stem cell research, biology classes inherently discuss stem cell research. So they're going to have some inherent background knowledge that might affect their viewpoint. They might be inherently pro or con that based on the fact that they've recently studied that. So that is going to be the bias. Last part is the CEO of a large company first divides into groups and then picks within the groups. This is an example of a stratified sample. We split into groups, and there's no reason to believe that this would be biased. You split into groups by gender, male and female, and then you pick 20 randomly within each group. No reason to believe that that would be an unfair representation of the population with the current information. So that is it. Thank you very much. Have a good day, and stay curious.